Hello everyone, I am Anurag Vandur. So in this video, we will go through the Indian astronomy discoveries of Aryabhata. So Aryabhata was one of the greatest mathematicians and astronomers of ancient India who lived around the 5th century. His work laid the foundation for many modern scientific concepts that we still use today. He explained us how Earth moves, how eclipses happen, and improved maths used in astronomy. Through this topic, we will understand how ancient Indian knowledge contributed significantly to the development of science and how Aryabhata's discoveries were far ahead of his time. In this slide, we can see the introduction part. Indian astronomy is a key part of Indian knowledge system. It was developed through observation, mathematics, and philosophy. It focused on planetary motion, eclipse, and time calculation. It integrated science with spirituality and daily life. Ancient scholars made precise astronomical predictions without modern instruments. It was developed through careful observation of the sky, along with strong foundations in mathematics and philosophy. The focus on Indian astronomy included planetary motion, eclipse, and accurate time calculation. These were important for making calendars and daily activities. Astronomy was also linked to festivals, seasons, and traditions. This shows ancient India had very advanced knowledge. In this slide, we explore the connection between Indian astronomy and Indian knowledge system. Astronomy, which is also known as Jyotisha, is an important part of IKS. It helps people understand time, seasons, and events in the sky. Aryabhata combined mathematics with astronomy to make accurate calculations about planetary motion and eclipse. This made Indian astronomy very advanced in those days. He also developed innovative methods to solve complex astronomical problems. His ideas influenced scholars in India and other countries. It shows that science, maths, and knowledge were closely connected in ancient India. Aryabhata was a pioneering mathematician and astronomer of ancient India. He lived in the 5th century CE and contributed significantly to IKS. He combined mathematics with astronomy for accurate calculations. This helped him make correct calculations about stars and planets. He developed innovative methods for solving astronomical problems. He approximated the value of pi as 3.1416, which was very accurate for ancient times. This value was very accurate and close to today's values. It is used in astronomical calculations. His work made Indian knowledge system more scientific and stronger. Now we can see the scientific approach in Indian knowledge system. IKS promotes questioning, reasoning, and logical thinking. It encourages observation and experimentation. It avoids blind belief and superstition and focuses on empirical evidence and analysis. It integrates theory with real life applications. Aryabhata used mathematical models for astronomical predictions and emphasizes learning through experience. It reflects a rational and scientific approach within traditional systems. In this slide, we can see the Earth's rotation in Indian solar system. Aryabhata proposed that the Earth rotates on its axis. This explains the occurrence of day and night. At the time, people believed that the sun moves around the Earth, but Aryabhata proved that this idea was incorrect. He gave us a simple example. When you are sitting in a moving boat, it feels like the trees and surroundings are moving, even though actually you are the one moving. In the same way, the Earth is moving, but it looks like the sun is moving in the sky. He also demonstrated logical reasoning and observation. This shows that Aryabhata had a very strong thinking, observation skills, and advanced scientific knowledge for his time. Now we can see the mathematics in Indian knowledge system. Ancient Indian scholars like Aryabhata used mathematics to study how planets and stars move. Important concepts like zero, number system, and decimal system helped them do big and complex calculations easily. They also used trigonometry, which is the study of angles and distances to measure how far planets are and how they move. With the help of these mathematical models, they could understand eclipse, position of planets, and time accurately. This shows that the Indian solar system, math, and astronomy were closely connected, and their ideas were advanced, which later helped in modern science. In this slide, we can see the time and calendar system. Aryabhata calculated the length of year accurately, which is 365 days. He developed a precise methods for measuring time. They used the movement of sun, moon, and stars to measure time. This knowledge helped create the Panchanga, the Indian traditional calendar. It is used to decide festivals, farming activities, and daily routines. This system also helped people understand seasons and weather changes. It shows that the Indian astronomy was not only scientific but also very useful in daily life. In this slide, we will go through the planetary motion in Indian solar system. Aryabhata explained the motion of planets using mathematical models. He introduced the idea of relative motion. He explained that what we see in the sky depends on the position on Earth. This is called relative motion. He also calculated the positions of planets very accurately, which helped in understanding events like eclipse. This shows that ancient Indian scientists had strong logical thinking and advanced knowledge. Their ideas were very developed even compared to many other civilizations at the time. Now we will go through the knowledge transmission in Indian knowledge system. Knowledge was preserved through Sanskrit texts and manuscripts. It was passed orally through Gurukul system. It emphasizes on memorization and understanding. Teachers, gurus at the time played a key role in education. Knowledge was shared across generations, and use of verses made learning easier. It encouraged discipline and deep learning and ensured continuity of scientific and cultural knowledge. So here we can see the global influence of Indian knowledge system. The Indian knowledge system had a big impact on the whole world. Ideas from Indian astronomy and mathematics, especially by Aryabhata, were shared with Arab and Persian scholars. Later, these ideas reached Europe and helped in the growth of modern science. Important concepts like zero, number system, and trigonometry became used all over the world. Indian texts were translated into other languages, which helped spread this knowledge. This shows that India played an important role in global learning, and different cultures learn from each other and build knowledge together over time. So we can see the relevance of Indian knowledge system today, which is very vast. It promotes scientific thinking and innovation. It encourages sustainable and eco-friendly practices. It is useful in modern education systems. It inspires pride in cultural heritage. It helps integrate traditional and modern knowledge. It is relevant in astronomy, mathematics, and philosophy. It is important for preserving indigenous knowledge. The Indian knowledge system made great progress in astronomy, but it also had some problems. It had limited technological tools for observation. Some concepts were not experimentally verified. Knowledge was restricted to certain groups. The slow spread of information across regions. Lack of documentation in some cases, and challenges in adapting to modern science. Despite limitations, contributions remain valuable. Now lastly, we can see the conclusion. The Indian knowledge system shows how advanced and rich ancient Indian science was. The work of Aryabhata is a great example of this. He used maths, astronomy, and logic to explain natural events clearly. His ideas not only helped India but also influenced science in other countries. This shows that ancient Indians had strong logical thinking. Even today, these ideas are useful and inspiring. Overall, the Indian knowledge system teaches us to learn from traditional knowledge and use it to build better and innovative ideas for the future. Thank you. I hope this presentation helped you understand the importance and relevance of our rich scientific heritage. Thank you once again.